So in the last lecture, we started the graph and we started with the position time graph. And in fact, we saw some graph as well in the position time graph. Two things we understood from the position time graph. One, the tangent, the slope of tangent, and the other was the slope of secant. Now, the slope of tangent gives us the instantaneous velocity at the point where the tangent is drawn, and the slope of secant gives the average velocity between the 2 points whose slope we are trying to define. So let's try to understand this. So if I draw any position versus time graph, let's say you start from here, so you go above, so in the time axis you go like this, you come back, you come back, then you touch this. From origin you turn, go back, you go up even further, you come down, you go on the other side of origin, and then you go here. Okay, so now this is the anyway, so it doesn't matter how you go and all. So now what we have, we can draw some perpendicular and we do the points, the peak points, right? That's the peak is here. It's here. All right. So now what we'll do, we'll do some draw some horizontal lines. Different lines. For every end, we need to do the horizontal line. Okay, so I may not be very much accurate in drawing this, but you can understand. So this is 0. Let's call it x1, x2, x3, and x4. Okay, this should also be given a name minus x5. Okay, so this is t1, t2, t3, t4, the end of the t5. Now, what you're supposed to do is by looking at the graph, find average velocity for the entire journey. Also, find average speed for entire journey. Here, entire journey means till I have shown the in the graph, okay, like t5. So from the time t equals to 0 to t5, this is the interval, and for this interval, you're supposed to find the average velocity and average speed. Okay, so tell me what is answer.
Sir, sir, for velocity we have to find a slope, right? So,
Yeah,
so how can we directly find the slope of all these things?
so the average is always defined between two endpoints, like some interval will be given to you. So you will not find the slope of something random. You have to find the slope of that line which begins at the first point and ends at the last point. Or even there is no need to go for slope. You can go by the definition. What is the definition of average velocity? Can you tell me the definition? Can you tell
So
me the definition?
total displacement upon total time interval.
Exactly. Yeah. So now that is pretty easy to look in the graph. If you look at the graph carefully enough, you will be able to see the total displacement part. And just what you need to observe is where you were and where you are. So that's the end of the game.
So it will be x2 minus x1 upon t5.
Uh, what is the final? Final is where is the final?
Sir, at point t means at t5
Yeah.
tx
So no, T5 is the time now. What is the final position?
x1
And what is the initial position?
x2
So what is the definition of average velocity?
x1 minus x2 by t5.
Correct. It's x1 minus x2. Although it will be negative, but that's okay. So the average velocity part is pretty easy. You can just write as x1 minus x2 by t5. Okay.
Sir,
So
I
now,
first got the same answer. Sorry, I got a wrong answer that x2 minus x1, but I went with the same process. Sir, but in
yeah.
this question, if they have not mentioned that it is on the point t5 and x2 and x1 like that, they have
Pardon.
like they have said to find the answer numerical in the numerical way. Then we have to find the we
No,
have to
no,
find.
no. See, the velocity is a vector quantity, and therefore it can be positive or it can be negative in one dimension. So negative means it's going towards the negative x-axis, and positive means it's going towards the positive x-axis. That's the meaning actually. So numerically also you write x1 and x2. Like you have to write the x1 minus x2, and if the answer turns out to be negative, it's totally okay. So numerical doesn't mean it should be positive. We are not finding the scalar quantity. Now the positivity we only search in case of scalar calculations. So the next part is given there. Find the average speed. Now there you need to only think of the value, not the sign. Understood? So this is a very important part that you must understand or learn that in velocity calculation, don't try to make something positive. If it is coming out to be negative, it's totally okay. All right.
Sir, average speed will be.
So for average speed, what we calculate? We calculate the distance
Total
traveled.
distance upon total time.
Correct. So now tell me what is the distance traveled as per the graph?
Yeah, sir.
Sir, it would be x3 plus x4 plus x1 minus x2
No,
divided by.
you need to understand that x1, x2, x3 are the position, not the distance. So how much you travel, you need to count, not what is written there. So
Sir,
for first of all, you go from 2 to 3, right? And then you turn back. So
sir, can I say answer?
yes, tell me.
Sir, it will be 2x3 minus, sorry, 2x3 plus 2x4 minus x2 plus
Okay.
again plus x5. Sir, I have a doubt in this. Sir, minus x5, does it mean, so we have to count the positive x5, right?
Yeah, x5 is positive.
Yeah, sir. So it will be plus x5,
Mhm.
uh, sorry, 2 plus 2x5 plus
Mhm.
x1.
Okay, so seems like that should be correct. I mean, just I will confirm. So it is x3 minus x2 for the first part, and then it is x3. minus 0, the other part. Like you turn back and come to origin. And then you go to x4. And then you come back to origin. So it's 2 times. Okay. So then you go down. So x5, 2 times. So basically, it's if I write this, okay, anyway, so this is fine. X, you go down and you come up. So x5 will do 2 times, and then you go to x1, and then you divide by t5. This is the average speed. So 2x3 and 2x4, 2x5 minus x2 plus x1. Now you can like compare your answer.
Sir, I just want to know that. Sir,
Yeah.
why it is 0 minus x3,
Why it is?
not 0 minus
Okay,
x3?
okay. I'll tell you. See why you are guys are feeling difficulty in answering this question. It's very easy answer. See, the t-axis should not be looked for. What you need to look is only the x-axis, which is the vertical line. So how you're moving? You're moving from 2 to 3 up, then coming down, then going up, coming down. You're on the same line. You're not on the x side. The t-axis is the time plotting actually. But how are you moving? Do you realize that how you're moving? You're not moving this way. So you're moving like this. You're going from here. Look at this carefully. Go up, then you stop. Then you go down, 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 down. You stop because the tangents are 0. So everywhere when the tangent is 0, velocity is 0, so you stop here. Then you start going up till here. You stop. Then you turn back. You go down, 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 down. You don't stop. Now you stop here. And then you go up, and then here I'm stopping the journey. Like my journey is ending. So I don't think it's difficult to calculate the length. How much is this length? Just common sense. There is no physics actually. It's a common sense. How much is this length? Come on. What is
Sir,
this length?
x3 minus x2.
And then what is this length? The full from here to here. How much is this length?
Sir, that x3.
That's
x3.
yeah. And then how much is this length till here?
x4.
How much is this length till here?
x4.
How much is length till here?
x4 plus x4.
From here to here only. From read the question carefully. How much is length from here to here?
x5.
How much is this much?
So which
From here to here.
minus x4.
Come on, distance.
x5, so that's
How much is the distance is? X5.
yes,
And how much is the distance here? This one.
x1.
So that's your distance. Now you know how to measure the length of the path. What is the definition of distance? It is the length of the path traversed by the body. So you're supposed to stick to the definition. Why you're trying to look at this line? This is the time axis, and therefore, when you're moving this way, and if I'm plotting against the time, then that is a graph. So to see where you lie, you need to draw a perpendicular from every point on the back to axis. Clear? Understood?
Yes.
Okay. If not understood, then you have to go back to again calculation. Do the calculation till you get it. So
Sir,
do
yes,
your
understood.
calculation. Yeah. All right. So the average speed and average velocity, these are two very important aspects. Okay, and we can do it graphically. Yeah. So graphically means without actually writing this, like, but for average speed, we have to only go this way because there's no option. For average velocity we can find from the slope. Slope is only meant for vectors. We don't use slope for the speed actually. So what is the average velocity? It is final minus initial upon. That's simple. So this looks like a tan theta only, and you can join the initial to the final, something like this. So you get a very small tiny triangle. This is the triangle, and what you can write is tan theta equals to how much? What is tan theta?
Oh, sir, it's x2 minus x1 upon t5.
By t5,
T5.
right? Okay. Now slope. This is not slope. Slope is let's better you call it alpha. Okay. So you need to realize something more than that. So this is tan alpha. Now slope is something that we always measure by taking the angle from the positive x-axis. This angle is slope. This is theta. So we know that theta plus alpha is how much? 180. So we can write alpha equals to pi minus theta. Okay. So let's substitute there. So tan pi minus theta is x2 minus x1 by pi. But tan 180 minus theta is minus tan theta. And you can see that slope not turning out to be what we expected, right? So the slope is 1 minus, sorry, this is 2. Why am I writing 5? Yeah. So you can see that this is what we were expecting, and that's the average velocity. So even graphically it's coming same, but graph is not required. Now the slope is always tan of that angle which the line makes with positive x-axis. All right. So tan theta is slope, not a tan alpha. Tan alpha is not a slope. Or you can simply say minus tan alpha is slope. Up to you. Okay. All right. So let's do this problem. So imagine a particle start from rest, maybe, and it moves in a very nice fashion. So it goes. It starts from rest actually. So initial tangent must be 0. So it goes this way. It accelerates maybe for some time, and then eventually it stops. So you can see the tangent is again 0. Now xt graph, how to understand where you stop? So that's also interesting point. So everywhere we can where you can draw a tangent parallel to the x-axis, we have zero slope. See, zero slope. You can see here
Yes, sir.
zero slope. So these are the points at which the slope is 0. It means velocity is also 0 because that's the definition of slope. So every point where the velocity vector is 0, you will get a slope parallel to the x-axis, that the t-axis in this case. Understood?
Sir,
Hmm.
sir, what is frame of reference?
What is frame of reference? Is that the question?
Sir, that's
Okay, a frame of reference is a Cartesian coordinate system attached to the observer.
So because it is in the HC or that project animation part.
Hmm. So first of all, there is something called observer. I think okay, I might not have explained, maybe have explained. So we
so.
have something
So you
observer.
explain this part.
Yeah. So you have something called observer, and when you attach a mathematical coordinate system, like a mathematical parameter, something a framework, you can say, then that observer becomes frame of reference. So it's just concept. Okay, I explain this what is the meaning. Now look at this diagram. How many tangents we can see where it will be zero? There are two tangents, obviously, one at the origin. So one for sure is at the origin. If we try to draw a tangent here, it will be parallel to the t-axis or x-axis. Or if you draw at the topmost point, again it's a you can understand. Okay,
Yeah.
so now the particle is moving this way. So there's something very interesting happening. For some duration, the graph is concave up, and then for some duration, the graph is concave down. So the blue marker is the maybe some hypothetical intersection where things are changing, and at this point, the concavity is changing into convexity. Okay, so the second derivative will change from positive to negative. So before this particular blue line, the second derivative may be positive, and just after this line, the second derivative may be negative. So we call something called the point of inflection also. Anyway, so second derivative gives the sense of curvature or concavity or convexity. Now in this particular case, the particle is first accelerating, then decelerating, and then it is eventually coming to rest. But in the entire journey, you are always moving away from the origin. So the journey is indeed only this way. So you never turn back, right? Because the journey I'm stopping, we are stopping the journey till it stops only, right? We are not counting after that. I hope you are getting the idea of what I'm saying.
Yes,
So
sir.
this is the end of the journey, right? The journey ends here. So how you were moving actually? So if you look at yourself, you're not moving this way. Your motion is the blue line, the blue arrow which I have drawn is your motion, and that's the only motion. Okay? So you start from rest and you end again at rest. So when you start from rest and when you stop at rest, the only way this can be achieved is accelerate and deaccelerate both, right? So if you are accelerating for some time, you must deaccelerate for some other time so that you can go back to rest condition. So if something is only accelerating, will it come to rest ever?
No, sir.
So if any journey begins from rest and ends at rest, it means if any journey begins at rest and ends at rest, it means
So
some part of the journey must have acceleration and some
just
part
the
must have
first
retardation. Yeah. Now again, there are two things to learn from here. If I say that the acceleration was greater in magnitude compared to the deceleration magnitude, it means you must have accelerated for the less duration and decelerated for the more duration, right? Are you getting this point?
Can you
No.
repeat, sir?
Let's say the magnitude of acceleration is more than magnitude of deceleration. Like you can accelerate very fast, but you can deaccelerate slow. So how are you going to divide your journey in intervals to start from rest and end at rest? So
So
will you
the
take more time?
acceleration would be
Yeah. So the acceleration duration should be less or more.
acceleration would be
Less.
less.
Yeah, go ahead. Yeah, once again.
Less.
Less,
less.
right? Yeah, common sense. So the acceleration must be for lesser duration, so that we can, with less deceleration, we can have more time to come to rest, and the vice versa. So if I say that the retardation or the deceleration magnitude is greater than acceleration magnitude, then what will do?
Sir, what?
If I just interchange the situation, then how the interval should be divided? If the deceleration is very powerful, then acceleration.
So
Like
then the
you can
acceleration would
decel first.
happen in very small time, small interval.
I'm
Then
saying that deceleration
acceleration
is
would be
much
more.
more than. Okay, you have need to listen to this problem statement first. The deceleration part is dominated over the acceleration part. It means the magnitude of deceleration is more than magnitude of acceleration. Then how are you going to divide the interval? In simple term, the A
So then
retardation.
acceleration would be more.
Pardon? Yeah, correct.
Acceleration would be
Yeah. So it means you need to accelerate for the longer duration and then de-accelerate for the smaller duration, right?
yes.
So you need less time to decelerate to come to rest, right? I think this is not a difficult thing. Now the comes situation when AR is equals to A. So what happens when AR equals to A?
So the magnitude not more.
What happens when AR equals to A? In such case, if you start from rest and end at rest, then you must divide equally, right? You must divide equal intervals. So the journey must be having half for the acceleration and half for the retardation. So if I make it like a diagram, like if I divide into intervals, so if this is A and this is AR, then A is less than AR. That's why this is the diagram, right? And if I draw something
Yes.
like this, it's A and AR. So the A is much more than AR value wise. Okay? In magnitude. In magnitude. Now, why this idea is very, very important. So we are very soon we are going to learn the velocity time graph, and there we need this idea to plot the graph accurately. So we should understand that the moment we have the beginning journey line, you start a journey from rest and you end the journey at rest. So the interval will have some time acceleration and some time retardation. So that's the only way we can achieve this. And okay, now coming to the graph we are discussing. So if you look at the instantaneous velocity, so how to get the instantaneous velocity? By drawing a tangent.
So dx.
So for instantaneous velocity, we have to just draw tangent somewhere on the graph, right? And the direction of tangent, like with the slope of tangent of this tangent will give you the instantaneous velocity, right? Okay. So now what we are trying to understand is that starting from zero, find that interval whose average velocity is same as the instantaneous velocity at the end of interval. Now this language is pretty difficult to decode. So I'll put into a proper language. This question is from again IE Eurodev. So let me define in proper language. So what this question? So you all have a Eurodev book. Have you purchased that book? No.
So that small green one.
Yeah, the small green one, green, red, whatever color. I don't know. in which color it is nowadays available. But yeah, so
Sir, but it is available online, so you can solve questions from there.
yeah, it is freely available online, and you can download it and then you can solve it. So just go to any site, maybe archive.org or maybe pdfdrive.com. So these are a really nice website for book downloads, free pdfdrive.com. So you'll get almost all books for free. Okay, you get every book of maths, physics, chemistry, whatever, history, civic, geography, computer science, all you need, you can get it here. So okay, let me put this question into word. So where is my box? So a point moves rectilinearly in one direction. So now this graph is one dimensional graph. That is, you need to realize you're not moving this way. The curve is not representing the direction of motion, it is representing the time versus position graph. Okay, as shown in figure above. As shown in figure above. Okay. The distance is traversed by the point destination. Okay. So the question is sketch the time t naught at which the instantaneous velocity is same as the average velocity for first t naught second. It means the average from 0 to t naught will give you same answer as the instantaneous at t naught itself. Now this is something you need to think about. I mean, this is not so obvious at first go. Maybe if it clicks, it's wonderful. Else, I'm always there.
Sir, at point of inflection.
Okay, maybe. So, okay, what you need to think is how you draw the average. So for average from 0 to any time t, you draw the line and you find the slope. Let's say I take a random point here. So if I take a random point here and if I try to find the slope, this is slope. You can see, right? This is the slope. So this tan theta will give you the average velocity from origin to this point, the t. Now, what is the instantaneous velocity at t? It will be along the tangent. The instantaneous is like this. Now you tell me, is this angle and this angle, are these angles equals?
No, sir.
No.
So the t must be selected in such a way that these two must be same actually. That's why.
Yeah, sir. I was solving that only. Sir, because
Go ahead.
the tangent, sorry, the slope of secant and slope of tangent should be equal.
Mhm.
Sir, then at
So,
starting and end point, it will be same.
so for that matter, what we need to do is just start from the origin and draw a line which is tangent to the graph. Yeah, I got it. See, at this point, this is the tangent to the graph also, right?
Yes.
So this is the approximate point I can see where even if I draw a tangent, it will match with the same line, isn't it? So this is the point. I got the point at point P. So at if the t naught, if I do the t naught here, you can just take a ruler and draw the tangent to the, I mean, like draw the put the ruler in such a way that it touches the curve at point P. So it means if I find this slope or if I find this slope, both will be same. So that is the meaning of the instantaneous velocity at t naught is same as the average from 0 to t naught. So that is the secant becomes tangent at some point. Difficult to realize, but if you realize, it's really great.
Understood, sir. So the average velocity is between the interval 0 to t naught.
Correct. And the instantaneous is at t naught.
Yes, understood.
And it's very easy. You just need to do the tangent actually. Okay. So for example, to understand this even further, let's say if I draw some graph, maybe like this. And if I ask you that beginning from this point, not from origin, let's say t naught, find the another point on the graph at which, like for which, or you can say the average value from t naught to that point is same as the instantaneous of that point. What will you do? So I am giving you this point as the beginning point. The other point should be where?
Sir, it should be in the second crest.
Yeah, it should be somewhere near the crest, not exactly crest, because it will be touching here. So
Yes,
my
sir.
tangent will be like this. So not need not to be crest. Crest is somewhere ahead actually. So you will get before the crest, slightly before. Okay. So you cannot draw a tangent to the crest from the other point, isn't it? Below or above. So what we can see that before the second crest, there is a point P whose tangent, if you draw, will be same as this line slope. So slope of this line is same as the tangent at this particular point. So the tangent of point P, so velocity at P is equals to the average velocity from T naught to T. That's the meaning. That's a very, very difficult part. This is the most challenging part that one should be, familiar with. So these kind of questions are actually difficult one, not the easy one. So I hope this is clear to all of you.
Yes.
All right. So
Sir, please will you give one more question solved like this?
yeah.
7.
You want this one? This one?
7 next. Not this.
Next, nothing is there. This is the only page.
So done.
So, so you all can download the IE Eroda book. That is a basic repository you must have. And most of my questions will be from that book. So, okay, so next part is we can go to the displacement time. Now there is no difference between the displacement time graph and position time graph. The only difference is the displacement is defined as change of position. So when you plot a displacement, when you plot a position, the only difference you will face is the beginning point of the journey. So in case of position time graph, we have seen that you can start at origin, above the origin, below the origin. So your position can be anywhere, but the displacement only happens when you travel something. So when you are at, let's say that there are three athletes, one is here, one is here. So what are their displacement? Zero as of now, right? So all three athletes may have different position, but at t equals to zero, what is their displacement? Can you tell me?
Zero.
Zero.
So it is zero for A also, B also, C also, right?
Yes.
So now the A may have traversed this much, B may have traversed this much, A may have traversed like. So now after 1 second, let's say I find A here, B here, C here. So all will have some displacement. Some will have more, some will have less, depending on how fast they are moving in 1 second. So every graph will begin from origin. Now depending on the acceleration or the nature, it will have some variable slope or may have constant slope. So now what I do is, for every graph we always analyze for the slope and the area under the graph. So let's say think of slope. What is slope here? So slope will be dy by dx. What is y here? Ds. What is x here? But by virtue of definition, the ds by dt is also called instantaneous velocity. So this part is the instantaneous velocity. Understood?
Yes.
This part is the instantaneous velocity. This is what we need to realize. Okay. The idea is that if you try to find the area, it will give you more sense. Area is y dx. That's the definition of area, y dx. What is y here? Now there is no physical meaning of this quantity. S dt gives nothing actually. So displacement in time will have no physical meaning. So that's why we will discard the area part and we will stick to only slope part, because that will have some physical sense or meaning. So let's say if I draw some graph like this. Now these two arrow representing two different athletes, let's call it A and B. And if you look at the slope, is it constant or variable?
So it's constant.
And if slope is constant, then what we can infer?
That velocity is constant.
So both the athletes are moving with uniform velocity, isn't it?
Yes.
And in which direction are they moving?
Same direction.
It is they are moving this way, not this way. Okay, come on. This is not the motion. Motion is
Yes.
happening here.
Yeah, so same direction.
Towards
Yeah,
S.
towards this. So all are moving upward, like along the s axis or displacement axis. This is the movement actually. Okay. So now, because slope is constant, so we can say VA equals to tan alpha. That's easy. And VB equals to tan beta. Okay. So in fact, we can find the ratio also, VA upon VB equals to tan alpha upon tan beta. Okay. All right. So the first thing first. Let's do the next thing. So I hope you are getting the difference between the displacement and position. In displacement, every line we must draw from origin. You cannot draw something else from the origin. Okay. Now displacement time graph can be accelerating also. need not to be always decelerating or uniform. So imagine if a particle is starting from rest and accelerating. So how the graph will look like? Starting from rest means at t0 the slope must be 0, and for slope to be 0 the tangent at the beginning must be 0. So you must start moving. So your graph must be starting something like this, because if you go this way then slope is 0, right? And then you accelerate. So if you accelerate uniformly it will be parabolic graph. So most of the case will be uniform acceleration, but it is acceleration which is positive, let's say, and you start from rest. So the u is 0 and you start with some acceleration. So this is the graph, and this is mostly okay. If it is a is constant, okay, then it is parabola. If it is a is not constant, then it will have some other curve which I cannot predict unless I don't know the formula. So let's call this as a positive u0. Now the other graph you can plot is if the if you touch the y-axis in the beginning, then this is the see you're touching the y-axis. So in the beginning, your slope is having some value. It is not 0, and it is neither along the y-axis. So we are having a tangent which is slightly tilted, which is difficult, slightly difficult, I believe. But I'll keep it tilted, otherwise it will become infinite velocity. So this is the slope. Let's you can see that even at t equals to 0, the tangent if you draw, it is not 0. In fact, it is having some value. And therefore, the journey of this blue line is starting from some non-zero value, but the acceleration is negative. So you're actually slowing down. Why? And how we can say this? You're slowing down. If you draw tangent in further, the slope will decrease only, right? It's a decreasing slope. Can you see that? So every time you go ahead and draw tangent, it will be lesser value, less steeper, right?
Retarding.
So yeah, so it's a case of retardation because it's decreasing. So the two graphs are very common. The u0, u not 0, a negative, and a positive u0. This is very famous graph. So from the looking at the graph, we should be able to identify uh, the nature of the graph, like what is happening actually. Now, if I say that it's a parabola, it means a will be constant. So you need to remember that if a is constant, the shape must be parabola. Okay.
Sir,
Yeah.
sir, if the acceleration means the retardation is also like uh, it is like minus 3 meter per second square. It is constant. Then it will be downward open parabola.
Okay, I'll tell you something again interesting. Yeah, it is downward in parabola in this case if it is negative, and if it is positive, then it's upward parabola. Okay. So you need to remember the simple definition. A is equals to ut plus half at square. But let's try to see in other way. Like you can write A is equals to at square or a by 2t square plus u. Now, if you look this carefully, this is like a quadratic equation. Can you see that? So this is something like y equals to ax square plus bx. The c part is 0. So you can see. Now, if you know the property of quadratic equation, so we know that if a is positive, it is upward parabola. But here A is not acceleration. Here A is coefficient of x square. If A is negative, it is always a downward parabola. This is what we know. And A is always not equal to 0. So A is either positive or a negative. So this is the quadratic property. And if you look carefully, this is also a quadratic equation in time. So instead of x, we have a variable called time. And because this is a quadratic formula, so whether it is upward or downward depends on this sign. So if you say A is positive, this is also coefficient is positive, and so it is up upward parabola and vice versa. I hope this is clear to all of you. Understood?
Yes. So that
The sign of U doesn't matter for the graph. Yeah, go ahead.
no sir clear.
Okay. So every, uniform acceleration, the displacement is a quadratic function. So when you write a displacement equation, the is equals to ut plus half at square, you actually deal with a quadratic formula, and therefore, okay, therefore we can think a lot about it. So there are various questions that we can solve only in the context of quadratic formula only. Okay. Okay. So this is the last graph from the discussion time. Then we can go to the next part. So understanding the meaning of acceleration and retardation. So let's say I'm doing a graph which begins maybe from rest or maybe not from rest. Like I can draw something like this one. All right. So you can see that even if you draw a tangent at the beginning, it is not zero, and in fact the end is also not zero. Right? So that is a kind of precursor to understand graph that you're not starting from rest. That's the idea. But what we're going to learn from this graph is something different. So the graph will have two reason. One is the acceleration part, then the retardation part. And something else. So let's divide the graph into four parts: O, A, B, C, D. And what we are supposed to understand is that in which part the particle is accelerating. So
A part.
the the segment you can analyze. So in OA, what is happening? Is it accelerating or retarding?
But
Accelerating.
it's accelerating.
And AB
Accelerating.
Retarding.
and BC
It's
Retarding.
retarding.
and CD.
Again
Retarding.
retarding.
Okay, so I think your notion of a retardation is not correct actually. That's the graph is representing. So I am saying the accelerating does not mean negative or positive answer. Accelerating means if the speed, the instantaneous velocity, if the magnitude is growing with time, we say acceleration. And if the magnitude is decreasing with time, then only we say retardation. So to understand the acceleration or retardation, what we need to check is only the magnitude part, not the sign. Sign is not something we are concerned about. So now will you change your answer now?
So can you repeat that?
Sir, then AB part is retarding and rest is.
Okay, so A part is retarding. What about the BC part?
So can you repeat that magnitude part?
Sir, it is displacement, so it is, I think so it is DC and CD is acceleration.
Okay, now what you can do is fundamentally you can check for the slope and just check whether slope is decreasing in terms of value. Like you can think of steepness, not the value. Like think of, is my slope going to be steeper as we move or flatter as we move? If it is going to be steeper, you are accelerating, and if you move ahead towards the right only and slope is becoming flatter, it means you are decelerating. Now that is idea you can continue with and tell me.
Sir, but slope we have to measure with the positive x axis. No,
Pardon?
sir, but with the positive x axis. No?
Sir,
Yeah, because slope is, see, I mean, you're getting what is normal like the slope in your school, not the mathematical slope, like a normal, playground slope. Steepness, how fast you can
Yes,
slide down.
yes.
So that notion is important actually to understand whether you're going to accelerate or decelerate. Don't go for mathematical stuff. Just go for the common sense, like a normal common sense. Now you tell me from O to A, the steepness will grow or decrease. That's it. O to A, my slope will increase or not. That's it.
Increase.
Over. That's right. Now from A to B,
Sorry, the main case.
O to A slope will grow or like increase or decrease. That's simple. Slope will means the steepness will increase or
No,
decrease.
O2 it will increase.
O to A
It will increase.
and A to B.
Decrease.
sir, it is retarding A to B, and sir, B to C, it is accelerating in negative, means opposite direction, and same with C
Yeah.
to D.
So in C to D, what is happening?
Sir, it is retarding
Student
because
Correct. So from C to D, it is again retarding.
sir, because the slope is again decrease, means it is going flatter and flatter at
Yeah.
this point D.
Yeah. So you can always, you can just mentally draw some tangent. You can feel it actually. It's not difficult thing. Now this is more steeper. This is less steeper. That's obvious. I think there is no rocket science here. Like if I draw tangent here, it says zero. So any point above will be steeper only. Common sense. And any point below is also like it is if you go from here to here. So you're going from the steepness to flatness. But here you are going from here to bigger value. So you can see the bigger value. So what we need to search for is the steepness is it growing or not. That's it. Okay. And slope is the fundamental skill actually. So you need to learn the slope in your brain. Like you need to draw the tangents all the time. So can you draw tangent all the time, everywhere on the graph, mentally always, and can see something, the event which is happening. Okay. So what I'll do, I'll make a box actually, a table. So let me make a table and there are four parts. Okay. So now let's see. This is Uh, So, uh,
Sir, what we have to do in this column table?
just a minute. You need to wait only. That's it. So okay, we don't need these many blocks actually. Just two blocks. So we can remove this one also. So now what we're going to do is we're writing the sign of each value. A means acceleration, V means velocity. Okay. Now acceleration and accelerated motion are two different concepts. Acceleration is a mathematical definition. That's it. When I say accelerated motion, so I mean speeding up. When I say decelerated motion, slowing down. That's the only meaning. Okay. So we need to identify when a motion is mathematically accelerated and when the motion is called mathematically decelerated. So look at this. First of all, if you go from O to A, every tangent that you can draw probably will be positive slope or negative slope. Or in other
Positive.
words, is it going to make acute angle or obtuse angle?
So it will be positive.
Correct. Now slope of displacement time graph gives what? Velocity. So from O to A, velocity is always positive. Let me say confirm this.
Yes, sir.
So from O to A, velocity is always positive. That is thumb rule. Now let's look at the acceleration part. As we go from O to A, slope will increase in value. So positive number is slope, and that number is increasing. A will be also positive. Why? Because acceleration is defined as V final minus V initial by time. So you can take two small interval and you can check the V final is always more than V initial, so difference is positive, and so A is positive. It is clear. So from O to A, we have realized that A and V both are always positive. Can you see that? Can you believe that? If yes, then we can say if the sign of A and V are same, it is accelerated. Okay, in fact, I should discuss this also. Now go from A to B. What about A to B? The velocity is still positive, but the velocity is positive, but the positive number is decreasing in value. So if you see A is negative. Why A is negative? Because the final velocity is less than initial. Because the slope final is less than slope initial. It is clear. From A to B, the final slope is less than initial slope. Do you realize this fact?
Yes.
So the A will be negative sign because if you calculate numerically, A will be negative. What about the V? Is V negative or positive? V only refers to slope. So any line, any tangent that you will draw from A to B will have positive sign. Is this clear? Is this clear?
Yes.
Okay. Now, can you tell me the sign of A and V from B to C and C to D?
Sir, from B to C, acceleration is negative.
B to C, what about the A? Sorry, velocity. Is V positive or negative? If you draw a slope, the slope will make obtuse angle with x-axis or
Obtuse angle, sir.
hmm?
Obtuse angle, sir.
Yeah. So the slope of obtuse angle, the tan theta of obtuse angle is always
Negative.
okay. So from B to C, velocity is always negative. Now check the acceleration sign.
Sir,
Check the acceleration sign.
Sir, negative.
Correct. Why it is negative? Because the V is negative, but it's increasing. So you can think of zero velocity here and some negative number here. A is final minus zero by some time, which is negative. So this is also negative. And what about the C to D? What about C to D?
Sir, C to D, it will be same as E to B. Oh, sorry.
No.
Acceleration will be positive and velocity will be negative.
Correct. Correct. Now you can realize something. And you can realize something very simple that whenever the sign is same, the support, the sign, same sign means the motion will be supported. It means it will increase the speed, the accelerated motion. So the accelerated motion means what? Accelerated motion means
Speeding.
when the acceleration, yeah, when the acceleration and velocity are having same direction, it will add up. It will, yeah,
sir,
accelerate. Yes.
yes, sir.
And decelerated motion means when they have opposite direction. So the third column, the third row will be which motion? Third row BC will be which motion? Accelerated or decelerated?
Accelerated.
And the last,
Or decelerated.
Deaccelerated.
so now
Sir,
there is, yeah.
sir, I got disconnected after you were saying maybe one.
Okay. So if you just look at the values, mathematical values of A and V, so you will get sometime positive, sometime negative, and in for the four different intervals, I have written all the sign. And what we are concluding that whenever A and V support each other, it means they are in the same direction, or mathematically they have same sign. All are equivalent statements. One, same direction, other, same sign. And whenever this happens, the speed will increase. So we say accelerated motion. If the directions are opposite, if A is negative and V is positive, it is decelerated motion, and vice versa also. If even A is positive and the V is negative, it is again decelerated motion. So the acceleration and deceleration depends on sign of both. Sometime in the examination they ask this question. They will give you the box and the sign of A and B, and they'll ask you in which case it will accelerate. So what you need to check whether they have same sign or opposite sign. Okay.
So just one more time, sir.
Hmm. Tell me.
So how that in the AB part, so velocity is positive, so but acceleration is negative. So that what I didn't hear because I got disconnected. Can you
Yeah,
explain
yeah.
that?
So velocity is defined as the slope. Velocity is defined as slope. If you draw any tangent in the segment AB, that will be acute angle only, and so velocity is constant. So that's straightforward. Acceleration is the difference of velocity. It means If you take a slope at A and if you take a slope at B, that's easy way to think of. Then the final
Oh,
slope
yes,
is
sir.
initially is positive, so the difference will be negative, and therefore A is negative. And similar, you can think of B to C also. So B is 0, finally is negative, so it is negative. And C to D is negative, negative, but the final negative is very, very small compared to the initial negative, so it turns out to be positive number. So you need to learn to how to subtract the numbers and so on. Okay. So with this graph, I will end the displacement time graph. So this is the most difficult one, probably. So let's go to the next, which is the most important part of our lecture, called the velocity time graph. Now, why it is most important? So we'll see or realize very soon.
So can you show the previous page? So done.
Just a moment.
Yeah. Yes.
Okay. Now we are going to the next topic called velocity time graph. And in the velocity time graph, again we'll start with our two basic assumptions. So what are our two basic assumptions? Slope and area. So we will try to see the first two things, and from there we'll try to infer the physical sense. So what is slope, by the way? Can you tell me something about slope?
So
So
it's
in
tan
this,
theta.
okay, what else?
So
So
acceleration.
slope always means dy by dx, right? That
So
is how we calculate.
acceleration.
Yeah, that's correct. So what is y here? Velocity. What is x here? T.
TV.
Now, if you look at this carefully, this is the definition of acceleration. So the first thing first, that the slope of the velocity time graph gives you instantaneous acceleration. So if you find the slope at one point, you get instantaneous. But if you find slope at not at between 2 points, you get the average acceleration. So for acceleration, you draw a tangent, and for average acceleration, you join the beginning and the end points, and you find the slope of secant. Again, the definition is same. But now something is also interesting, and that is the area. What is the area? What is the definition of
Displacement.
area?
YD.
YD.
So displacement.
Yeah, so we'll see that. So what is y here?
V. VDT.
So of course, when you multiply velocity with time, you get a displacement. That's correct answer.
So it is also written as dx square by d square x by dt square acceleration.
Pardon, pardon.
So it's also d square x by dt square.
Okay. Hmm. What acceleration?
Yes.
Yes, that's correct. So the area is y dx, and that is equals to v dt, and v dt is called displacement. We can also write by s. So now we can understand two things. S as the meaning of displacement, we write as v dt, and s in terms of distance, we write mod VDT. Now, how these two will affect graphically? So I will teach you how the graph of any function and its mod looks like. That's very interesting part. So imagine you are plotting some graph, some random graph. Let's say it's good to plot something like this, kind of sine graph. This is the graph of fx. How the graph will look like? So let me extend this line, and I just want to extend this line, and I want to draw the parallels. Okay, and we are going to learn this is y and x graph. So how the graph of y equals to mod of fx will look like? The answer is pretty simple. If something is positive, then mod will not affect, right? So we all know that mod of a positive number is same as the number, isn't it? So a positive part of a graph remains unchanged. That's the idea. So mod only affects the negative part of the graph. And what it does, it reflects back on the y-axis. It means if you take a mod of negative number, it will remain same, but it will become positive value. So the other part of the graph will look like this. So that is the difference between the a function and its mod. So to plot the mod, what you need to do, don't worry much, just plot the function the way you know, and then every part which is hanging below, or you can say every part of the graph which is negative, just throw back to the other side. Don't change the shape, it will remain the same shape, only you have to throw on the other side. So it will take the mirror image about this line, just like mirror image. That's the idea of modulus. So I hope this is not difficult to understand.
Sir,
But
dv by dt is the instantaneous velocity, instantaneous acceleration. No?
pardon,
dv by dt is the instantaneous acceleration. No?
yeah,
So,
correct.
so we in this VT graph we consider uh, the acceleration as for the short period of time we calculate it.
Yeah, correct. So VGT is for the short period, then you integrated to find the entire period, whatever period you are interested in. So displacement is always defined for an interval, right? So the limit of integration will decide the interval. Okay. Okay. So now while calculating the displacement, the sign of graph is important to be taken into consideration. It means a graph below the x-axis must be taken as negative and above positive. And even while adding these two numbers, you will keep the sign intact. But while calculating the distance, we'll take the positive value of each graph, like whether it's hanging or whether it is above the graph. If it is above, we add. But in case if some part is below, we first make it positive, or we can just take the value of the area. So we calculate the magnitude of area, ignoring the sign, and that's also obvious from the mod function. So every area becomes positive. So in calculation of distance, we first bring every graph on the above, and then we add all every value. So all value become positive. So displacement, you find the area with sign. Distance, you find the area without sign. Is this clear? I think this is also what we learned in class 9, isn't it? So this part I think you all are aware of. Are you?
Yes.
Okay. So what we learned from the velocity time graph? Three things: acceleration, displacement, and in also some case distance. And what is the difference between the displacement and distance? In displacement,
So
we
it's
take the
actually
area with sign. In distance, we take the area without sign, like only positive value. Okay. Okay.
yes.
Okay. Okay. Now something interesting. Also, we can deduce directly from the graph. So imagine if I think of a journey which is quite symmetrical. So the journey is it's going this way, this way. So imagine this positive and this negative is exactly the same. So what is the displacement for the entire journey? So displacement for the entire journey
Zero.
is 0,
No.
because it is about the area, and because we have equal positive and equal negative area, so the entire sum is 0, and therefore the answer is 0. So without solving, we can just by looking at the graph, we can say there is no displacement. That's simple answer. So the rule is area above and below should be equal in value. Then there is no displacement. Okay. But what about displacement distance? So in the same question, if
And
I talk
two
about
times of the
distance,
area of triangle.
correct. So if I say the area is A, so this is 2A. Yeah. All right. So you can say mod of A in this case if there is a risk of negative. Okay. So the things that we can always infer from the velocity time graph are acceleration, displacement, distance as well. Now, if a graph we plot in which every part of the graph is above the x-axis, in such case, the distance and displacement will be same. So if there is no change of sign, if there is no negative sign, in such case, what we can see, the graph will have same distance and same displacement, isn't it?
Displacement.
If I plot a graph of something like maybe something like this, I mean any random graph. So here nothing is going down, everything is above only. So we can say here S displacement and S distance will be same. One more case is if everything is down. So here we have that the S distance is mod of S displacement because we can't write negative numbers, right? So if everything is down, just take a mod to avoid the distance being negative. Distance will be positive. So that is very simple. And if we have some part positive, some part negative, so positive we add, and we make the negative as positive, and then again we add. Okay. So these are the formula that you need to apply. And let's talk something more about the acceleration. But the A we got is dv by dt, which is also the slope. So by looking at the slope, you can say A is 0 or constant or variable. So if I draw a line like this, what does it mean? In a VT graph, what a horizontal line represents?
So zero acceleration.
Correct. And if I draw a line which is like this or maybe like this, so these are the constant acceleration. Negative
Constant
in
acceleration.
retardation. So this is constant. So it is very easy to understand the nature of acceleration. So anything which is stepping up or stepping down will have or no. You can also identify which one is acceleration and which one is retardation. So if you are going towards the lower velocity, so if you go this way, it means you're retarding because the velocity is decreasing, right? So v is decreasing.
Yeah, sir.
In this arrow, v is increasing, so acceleration, and this is retardation, and this is acceleration is zero, so nothing is happening. So it is very easy to plot any graph. Uh, if I give you question of uniform acceleration, 1D problem, so what we do is we must try to solve most of the 1D problem in terms of velocity time graph. Like you first plot the graph, and from there you try to solve the question. Okay. So let's do some problem because we need to practice something. Let's do some problem. So theory of VT is over. So that's only VT graph. Now we have to do some problem. So what I'll do, I'll mention a problem. In fact, I'll write the problem. So read this question carefully and then you can answer. A particle starts from rest. Now try to create the picture. So in the VT graph, where you will start from? Origin. Okay.
Origin.
It accelerates uniformly with acceleration alpha. So alpha symbol I don't know how to write. In for some time, the time is not given, and then decelerates to zero velocity with uniform retardation beta. So I'll add later on. If the total time of journey is some symbol, then find the A max velocity of journey, B total displacement, C average velocity of journey. So some symbols are given, values are not given. So acceleration alpha for some time, and then this decelerates to zero velocity with uniform retardation beta. If the total time of journey is tau second, tau is a symbol, then find these values. So you can try for some time, then I'll solve if you want, and make sure that you solve by only graph. You can think of this. Can you plot the graph at least?
Yes, sir.
Yeah, go ahead.
Sir, it would be a like this graph, sir. Uh,
Hmm?
so the graph would look like
Like a triangle.
para.
Yeah, sir. My also triangle. Also got
Now
the same.
this triangle will be isosceles or scalene.
The scalene triangle.
Correct.
Isosceles.
No,
The
isosceles is not.
isosceles. The
No, no.
isosceles would be
Not
sir.
tell me. Listen. Is accession and retardation equal?
No, sir. That only I said scalene, sir.
Yeah.
I
If
also maintain the
if
same
it is
time.
not equal, it means the interval must be unequal because you start from rest, you end from rest. So we have discussed this. So if the beginning and ends are at rest, and if you have different value of acceleration and retardation, then the time taken for the alpha will be different from the beta, isn't it?
Yes.
Okay. So first you plot the graph. It will be you can just think of any alpha is more than beta or less than beta, doesn't matter. So choose alpha is more than beta and then plot the graph. How to look like? Alpha is more than beta.
Sir, I got three questions. So can I send you the photo?
Hmm?
So I got three questions. So can I send you the photo?
Yeah. Yeah, got it.
Sir, I've sent
If
you.
yeah, so in a way it's correct, but if alpha is more than beta, it means the alpha should have lesser duration than beta, isn't it? Alpha is more means we must accelerate for a small duration and retard for more duration to come to rest. Okay. If you put the VT graph, then you can draw something else. Maybe like this. It actually doesn't matter how you draw, but okay, if alpha is more than beta, then you should give more time to beta because beta is slow, isn't it? I hope you're getting the point what I'm saying. Now the entire journey is given, so that's like one. I mean, like one information which we need to hang on. So this is T1. So let's say I am dividing the journey into two parts. One is the T1 interval and other is the T2 interval. So the first information that we can write from the graph is the sum of the time is tau. That's the thing given to us, right? And the maximum velocity is something we can assume because it's not given. Now we know that the slope of the graph gives you the acceleration. Now this will give you acceleration, so this will give you retardation. So that's interesting part. So if acceleration is this angle, then the inside will be a retardation. So you can say this angle as not sorry. So this is theta, one is theta. Okay, so what are we can write about tan theta one? What is tan theta 1 by the way? It's alpha, the slope of this line. Just find the slope, the value. So alpha is the numerical value. That's it. And from the graph also, from the definition of tan theta, if you look at this triangle, what is tan theta by the way? Opposite upon base, right? Perpendicular upon base. And similarly, tan theta 2, which is beta, just by writing value. If you write the acute angle, you write the magnitude actually. So what you can write tan theta 2 by the way? What is tan theta 2?
Hmm. So we know.
In this triangle, look at this triangle.
So L.
That's it.
So we not upon T2.
So it's not difficult. So V naught upon T2. So we got T1 and we got T2. So from here you can write as T1 is V naught by alpha, and from here T2 is. You know what we do next? We substitute here. So we get V naught by alpha. So V naught. So V naught comes out to be how much? Alpha, beta, tau. So we have solved it graphically. Now, what about the displacement? It's easy now. What is displacement? We know the definition of displacement. It is the area under the VT graph. Can you see the area now?
Yes.
So what is the area?
Sir, it's half into uh,
So tau
but
into V naught.
Yeah, correct. So half into base into height. Base is tau and height is V naught. So that's the answer. We know the V naught in a way. So what is S by tau? It's called the average velocity by definition, total displacement upon total time, which turns out to be V naught by 2. That's nice. Anyway, so the S is how much? Half alpha beta tau by alpha plus beta into tau. So we got displacement as alpha beta tau square by twice alpha plus. And the average velocity is half of V naught. So that's alpha beta tau by twice. So now we have all answers. So is it difficult? So is this clear, guys? Tell me.
yes.
Now tell me if you have any doubt in this.
Sir, sir, please will you explain that acceleration means the angle, the tan theta 2 will be
No.
retardation.
See, I mean, you are getting so much confused. Acceleration is a slope of the vertical graph. Slope means tan theta. So if we have a straight line, it will have fixed slope. So just find the tan theta. And retardation will be tan theta too, because that other line is a retardation. So we find the magnitude of slope and we equate with alpha and beta. If beta is retardation, so what is the acceleration? Minus beta. Let's say if you
Sir,
want to write, yeah.
so then in every type of extension there is retardation.
Oh my God. So now you need to simply understand, if you accelerate for some time, then how are you going to come to rest? Can you come to rest without decelerating? If you have some velocity, then you must have some retardation to come to rest, isn't it?
Yes, sir.
So in this case, the retardation is always, it will be there, isn't it?
Sir, then the angle which was obtuse angle, the thing with the theta 2, then that angle is telling, means it is portraying about which acceleration?
Which angle?
The obtuse angle with theta 2, 180 minus theta 2.
Okay, that is the Acceleration where actually. See, I mean, the slope gives you acceleration, not the retardation. So how we write acceleration? Minus beta is the acceleration for the other journey is tan of pi minus theta 2. That's it. So slope is this one. This is the slope. What is the meaning of slope? The angle it makes with the positive x-axis. And what is beta given in the question? Is it acceleration or retardation? What is beta given? Is the beta given acceleration or retardation? Tell me.
Retardation.
So if retardation is given to you, then how you get the acceleration? Putting a minus sign. If I say your retardation is 2 meter per second square, then your acceleration is minus 2. That's the way of writing. Okay. अरे बाबा बोलो हाँ ना कुछ तो बोलो.
Yes, sir.
Okay. So minus beta is equals to tan pi minus theta will be minus tan theta, and this implies minus will cancel out. So it's good to write tan theta 2 only as beta. What does it mean? That you just take the angle, the magnitude, and then equate with the values. So alpha and beta are the values of acceleration and retardation. So you must take the acute angle to get the answer directly. So you can write directly without worrying about the actual definition. Okay, so if either you take this angle and then write this long process, but this long process will give you the same answer, right? The best way is like alpha is the slope. So for the first journey, alpha was constant. So from 0 to t1, this interval, the alpha is constant. And for the next interval of t2, these are the intervals, not the time. This is interval. So from 0 to t1 interval, alpha is the acceleration. So slope of this line is the answer. And from the next interval t2, we have the answer beta, which is retardation given in the question. Okay. It is clear? No.
Clear.
Yes, sir. Yeah.
Okay, let's go ahead. So the next question is, so the next question is, or you can do in this questions in tutorial. So you can go to the next type of graph. Okay. So I'll just finish the graph quickly so that you can practice more in tutorial. So next is called acceleration time graph. Okay. So what is the acceleration time graph? AT graph. Now let's try to find the slope. So what will be the slope here? Slope is in AT graph. What is A? What is on the y-axis?
Sir, A.
Correct. So how to write slope?
Sir, dA by dt.
dA by dt. Correct. Now we know that the dA by dt having no physical meaning, although you can call it jerk and all. So this can is d3s by dt square. We call it jerk. But this is no physical meaning to us, so we'll say no physical interpretation. So,
So what is it?
pardon?
Checks, jerk, flex, or
No, it is called jerk. Like the rate of change of acceleration is called jerk, but that is not something which we use in the classical physics. So if acceleration is also changing, then okay, that's complex. So we'll not discuss the slope part. Slope part is not discussed. So let's talk about the area part. So what is the meaning of area?
AD, ADT.
ADT, integration ADT, right? So area is integration ADT. Why dx? So always thinking this way.
Sir, velocity.
No.
Sir, why not velocity?
Now we know that A is defined as dv by dt. So this will become dv into dt by dt, which is 1. So A dt is as good as dv, and dv means what? What is the integration of dv?
V.
No, it's change in velocity. V minus U.
Oh,
It's V minus U.
And there's a huge difference between what you are saying and what I'm saying. So velocity and change are different. So A dt gives you the change in velocity, not the velocity. If initial is 0, then what you said may be correct. So what we need to remember that V minus U, the change in velocity, is area under AT. Okay, so this is what you need to remember. And rest again, I'm leaving for the tutorial part. So I'll share all of my questions with Amit sir, and he will discuss in the tutorial. Okay. So let's go to the other variety of graph. Now, conventionally, these are graphs which we need to be learning, but now there are some unique graph which is not easy to interpret in the beginning. But with the knowledge of slope and area, we can actually initialize the analysis. Okay. So if you know how to analyze any graph from the scratch, then only you can solve those questions. Okay. So these are not a fixed questions. So let's see some graph. So the next question is called AS graph, like acceleration displacement graph. So now the first thing is there any meaning to slope? So dA by ds looks like we are nowhere. So it makes no sense to us. Ignore it, like no sense. Let's talk about the area. I'll put a heading. Miscellaneous. What about
So
the
what is
area?
that wrong? Wrong in other symbol.
Area will be how much?
Where it would be somewhat would be dependent.
No, see, I mean, why you guys are not able to answer one question every time I ask me? Why you're not getting the algorithm right in your brain? It means you're not learning at all. Like I'm saying that area is y dx, slope is dy by dx, and this should be in your brain all the time. So every time if you're struggling to answer, it means you're not learning the basic actually. You're thinking something else. I don't know what you're thinking. What is area of any graph?
sir, integration of y to dx. Y dx.
So if I convert y dx into these new variables, what should I write here?
ADS.
Exactly. Now you should not confuse every time. If you're confusing every time, it means you're not learning the fundamental. Now ADS we got. Now what we can think of? A we can write as V dV by ds if you remember.
Yeah, sir.
So it's difficult to realize, but this is something you can add. And ds or ds becomes 1. So it becomes v
So
dv.
v square minus u square by 2.
Correct. So we say that v square minus u square by 2 is the area under AS graph. So let's call it A. So v square equals to u square plus 2a. That's the formula. So if you know, if they give you the AS graph, what you can do is you can find the area and then use this formula to get the final velocity if initial is known to you, or you can find the change. So that's again a very interesting graph. So now we'll see something even more interesting graph. So what about the v square s graph? So do we think that some sense will come out of this graph, the v square s graph? Now, if you look at the slope part, what is slope?
So is it acceleration?
Okay, what is slope? By the what is slope first?
dv square by ds.
That's very. What is area?
It is integration v square ds.
Very. Now this makes no sense. So ignore this. Now this is dv by ds something square. Of course, we can use the chain rule because we know that this we can simplify, and this will become how much?
2va.
So it's 2a actually. It's 2a because v d by ds is called acceleration, so it's twice of acceleration. What does it mean? If we have a v square versus s graph, imagine if I plot some random graph, and let's say if you do a tangent somewhere, so let's say the tangent to this graph is theta naught. So at point P, what is the acceleration at point P? So we know that twice of acceleration at any point is the slope. The acceleration at point P will be how much? Tan theta naught by. So it slope gives you double of acceleration. So what is acceleration? Half of slope, isn't it? Mason.
Sir, we understood.
A क्या लिखेंगे 1/2 of slope है ना, और स्लोप हमें मतलब कि क्वेश्चन में ग्राफ में स्लोप गिवन है, तो the slope given है तो we can find it easily, right? Not very difficult, but yeah, these are something very unique graph.
Sir, but this will be only applicable in the V square by.
Yeah, v square is graph. Now I'll tell you something very interesting. Let's draw v power any random graph. So v power n versus s power n graph, like a random graph. How it look like? How we can proceed? A random. So this is something weird. So what we do is we always, in v and s, whenever you see a v or you see s, just find the slope because area will anyway not make sense. So you find the slope. So dvm by dsn. That's how we write. Now this we can rewrite as dvm dsn. Okay. Now what we do next is something interesting. We write here dv. Okay, and we write here dv, and we write here ds, and we write here ds. Okay, not relax. It's too complex, right? So I write ds also and ds also. Why I'm doing this? Because I can differentiate this and I can differentiate this. and this all writing will not affect the overall structure of the answer. So the slope eventually turns out to be dvm by dv upon ds n by, and if you do not understand this much, you can leave this part, into dv by ds, which is from here dv and ds here. So it will give you some value, something. And this is not acceleration because we know that
A
acceleration is
by
g.
V.
Yeah, so just a moment. We can write as mv m minus 1. This is ns n minus 1 into dv by ds. But we need v dv by ds to make it acceleration, right? I can take one v common from m minus 2, and my job is done. V dv by ds. So whenever we have v and s, we can always bring the acceleration for sure. So slope is how much? mv m minus 2 upon ns n minus 1 into acceleration. So a is how much? Okay, that's bad answer. Into slope. So we can solve like question like this also. Okay. I'll give you something very interesting also. A random graph. These are some, like, of course you will not see like everywhere. In few instances you may come across these questions, like a rare occasion. A random. If I give you v versus t square graph, like at first go it's difficult, but the moment you see v and t, you know d by dt is acceleration, so you know you can do it actually. So we can write as slope equals to, sorry, what is slope? d by dt square, and then you can write as dv by dt into dt square by dt. Like, I know that this will be acceleration. This is a by 2t. You can see that t becomes 2t. So acceleration becomes 2t into slope. It's difficult to think at first go, but with practice you will realize that okay, anything can be possible. And then I start giving you graph of v per m versus t per m. So again, slope will be dvm by dtn. So this we can rewrite as dvm by dv into dv upon dtn by dt into dt, and that you know what I'm saying. mvm minus 1 upon ntn minus 1 into acceleration, because d by dt comes. So I have the answer that. So I can say acceleration equals to ntn minus 1 upon mv m minus 1 into slope. So how many types of graph you can imagine? An infinite graph is possible. Now the method to attack any problem of graph is think of slope and area. The moment you get some physical sense out of it, you're done. Now with practice, you will realize that you can actually get the sense in almost every question. So in the beginning, it won't be easy, but after some time, it will change. Okay.
Sir, please will you show the last screen, the previous screen. Sir, before that, not this one. Sir, before. Yeah, sir, this one.
Done.
Yes, sir.
Okay. So now with this, we complete the graph part, and we are done with the uh, entire graph and velocity. So what we're left with is called the motion under gravity, which is a very small part, and then we will done with the one dimension. Okay. 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 So I'm ending the lecture now, and we'll discuss in the next lecture motion under gravity. All right. So, okay.
So projectile motion comes in the 2D graph.
Yeah, it comes in the kinematics too. So we'll study after the motion under gravity. We will start the projectile motion in detail. Okay. So very soon I'm going to share my notes of kinematics, which is like a detailed notes you can always refer to also. You can keep it as a repository. You can revise easily from there also, because what you're solving is from the notes only. So I'll share the remaining part of the notes as a second discussing tutorial, and then you will get a fair practice of various concepts.
Sir,
Yes.
sir, because we completed the projectile motion exercise from kinematics in H01.
Very good. Very good. Okay, you have already you have completed the tutorial, right?
Yeah, sir.
And
Sir gave us homework to do 14 questions from the subject part, but I thought that I have missed any lecture of yours in projectile
no,
motion.
no, no, no.
I
It will
saw
take.
that.
Sir is trying to give you the the initialization. Like if you can start even without learning those concepts from the basic concept of your class 9, so it will give you boost. So when I will teach you projectile, you will see a different dimension. So don't worry, you have to wait for some time. So projectile is really huge concept, and you will see that we are going to learn very deeply and enormously. So we learn a lot of things. Don't worry. All right. Bye, guys. Take care.
Thank you, sir. Bye, sir.